Okay, Assalamualaikum. We meet again in the next video in chapter 2. Okay, so we will continue subtopics 2.4, data decoding and encoding system. Okay, encoding and decoding systems. For those taking principal communication, we have this topic in that subject, so this is not something new. Okay. Signal encoding techniques. Okay, so there are a signal, the data coming here, digital or analog data or information going into the encoder. Okay, so digital encoder, digital signal is coming out. Okay, encoding into a digital signal. So this is analog encoder into digital decoder. Okay, modulation onto an analog signal. So this is digital or analog data or signal. Okay, so modulator, analog signal, demodulator. Okay, so this is the output. This is the output from digital decoder, and this is the output from analog modulator. Okay, so you must be familiar with this signal. Okay, this is like on off. This is amplitude modulated signal, right? This is the frequency domain. This is the time domain, and this is frequency domain. Sorry. Okay, digital data signal, digital signal. So digital signal, this is the characteristic of digital signal. Digital signal is discrete. Discrete means one by one. Discrete. Okay, it is discrete. It is not continuous. Discontinuous voltage pass. So it is not continuous. It is discrete. So like this lah. For this signal, it has this part from here to here. For this signal, here. Discrete. Satu-satu. Signal satu. Signal here. For this signal, here. So it is discrete. 0, 1, 0, 1. You can see the difference between this signal and next signal. Okay. Each pass is signal element. So each signal element represented by one pulse. Okay, like this. So one pulse, for example, is 0.02 millisecond. So from this time or period, we call it period T, you can calculate the frequency, which is 1 over T is equal to frequency. Okay, binary data encoded into signal element. So binary data 01, 01, 110 can be translated into signal element. Okay, look back into digital communication systems. So we have analog source, for example, voice, or any other analog signal. Okay, so from this analog signal, it goes into A to D, analog to digital converter. Okay, for A to D, analog to convert from analog to digital, we can use pass modulation, passcode modulation, delta modulation. Okay, so this is we're not going deep into this topic because we assume you already heard or learned about this in other subject, which is reciprocal communication. So PWM, path width modulation, PPM, pass position modulation, PM, pass amplitude modulation. Okay, passcode modulation and delta modulation. Okay, then come into the source encoder. We have line coding, which is first is RZ, return 0, return to 0. Second is NRZ, non-return 0. Fourth, third and fourth. Okay, for channel encoder, we have binary modulation, ASK, FSK, PSK, and so on. ASK is amplitude shift keying, FSK is frequency shift keying, PSK is phase shift keying. Okay, and then before sending the signal, you have the amplification. That is the digital communication system. So what is line coding? Line coding is the process of converting binary data or sequence of bits to a digital signal. The pattern of voltage, current, or photons is modified to represent the digital data on a transmission link. So basically, before transmission, you need to convert the binary data to digital signal. So basically, for example, binary 1 maps or coded into 5 volts and binary 0 coded into negative 5 volts. Okay, so this is example. So in this case, we have 0101 digital data. So this encoder convert this digital data into a form of digital signal. Okay, so in this case, we have so this is 0, this is 5 volt, this is minus 5 volts. So 1 is coded to plus 5 and 0 is coded to minus 5. So the signal transmit here is in form of square wave pulse. Okay, square wave pulse with plus 5 and minus 5. So at the end of the receiver, the decoder will translate the signal here, digital signal, this digital signal into digital data. So 5 volt becomes 1 and negative 5 becomes 0. Okay. Why we need line coding? Okay, here we can see that the information, analog signal, here is the coding process, PCM, parse code modulation, and here when we get the binary data, the line coding is used to convert the binary data into digital signal. Okay, so why line coding? The purpose of line coding is to match the output signal to the channel for baseband transmission. Line coding also allow the following process to be done to the digital data. Okay, so apart from converting binary data 010101 to digital signal, which is like 5 volt and negative 5 volts, so line coding also use to achieve this the following process in the digital data. First is for synchronization, second is error detection, and third is error correction. Okay, so why is line coding? Why we need line coding? To be able to uh, be able to do this process: synchronization, error detection, and error correction. Okay, so this is the types of line coding or encoding schemes. Okay, we have ada gangguan sekejap. Okay, we will meet after this.